Well, hello there and welcome back for more Advent of Code. We're going to continue where we left off last time. That would be day 7, I think. Yes, indeed. Well, look at this. CD, ls, there. Is this some computer stuff? Okay, so day 7, no space left on device. You can hear birds chirping and raindrops hitting leaves as the expedition proceeds. Occasionally, you can even hear much louder noises in the distance. How big do the animals get out here, anyway? Okay, maybe that's a bit of foreshadowing for things to come. Let me increase the font size. The device the elves gave you has problems with more than just its communication system. You try to run a system update. System update, please. Pretty please with sugar on top. Error, no space left on device. Okay, so seems like our device is running out of space. Perhaps you can delete some files to make space for the update. You browse around the file system to assess the situation and save the resulting terminal output, your puzzle input. For example, okay, so we have some terminal output here, cd/ls. This seems to be the output of ls. And okay, so there's a directory A and some files, it seems, and a directory D with cd into A. And we have more stuff here. Okay. The file system contains of a tree of files, plain data, and directories, which can contain other directories or files. The outermost directory is called slash, or root, I guess. You can navigate around the file system, moving into or out of directories and listing the contents of the directory you're currently in. Within the terminal outputs, lines that begin with $sign are commands you executed, very much like some modern computers. Okay, makes sense. CD means change directory. This changes the directory in the current this changes which directory is the current directory for the specific result, but the specific result depends on the arguments. cdx moves in one level. It looks in the current directory for the directory named X and makes it the current directory. Okay, yes. cd ... moves out one level. It finds the directory that contains the current directory, then makes that directory the current directory. Okay. And cd/ switches the current directory to the outermost directory slash. I think I'm going to call this thing root. ls means list. It prints all the files and directories immediately contained by the current directory. 123 abc means that the current directory contains a file named abc with size 123. Okay. Dir xyz means that the current directory contains a directory named xyz. Given the commands and outputs in the above example, you can determine that the file system looks visually like this. Okay, and then we have a pre-printed tree of the file system. Okay, here there are 4 directories: slash, the outermost directory, A and D, which are in slash, and E, which is in A. These directories also contains files of various sizes. Since the disk is full, your first step should probably be to find directories that are good candidates for deletion. To do this, you need to determine the total size of each directory. The total size of a directory is the sum of the sizes of the files it contains directly or indirectly. Okay, yes, directories themselves do not count as having any intrinsic size. The total sizes of the directories above can be found as follows. The size of directory E is 584 because it contains a single file I with size 584. Okay, well, no other directories, makes sense. Then the directory A has a total size of 94,800 83 because it contains file F, okay, G and HLST, plus file E indirectly, A contains E, which contains I. Okay, I think this is all kind of a mouthful. Then directory D, I guess it's this one, has 4 files, and the total size is this. As the outermost directory, root contains every file. Its total size is this thing, 448 million, blah, blah. The sum of the size of every file. Okay. To begin, find all of the directories with a total size of at most 100,000. Then calculate the sum of their total sizes. In the example above, these directories are A and E. The sum of their total sizes is 95,437, and this comes from, well, the sizes of A and E combined. As in this example, this process can count files more than once. Okay, yes, because which one was it? I think E is contained within A, right? Yeah, E is contained within A. Okay. Does this make sense? Yes. So we are actually counting directories that are at most 100,000. So this would be like small directories. Find all the directories with a total size of at most 100,000. What is the sum of the total sizes of those directories? Okay, I don't know how this answer would help us save or delete things in the device, but I guess we're going to find that in part 2. But damn, this seems like a pretty involved challenge. So, okay, let's jump into the code. Let's go to Advent of Code 2022. Open the editor. Let's create a new daily solution and do the usual thing. Actually, we can maybe copy the signature of the previous one, and let's use it in main. So we're going to import this module, day 7, and have a day 7 here. Okay. And how should we approach this? Let's reload day 7 as usual. So we're going to need some parsing of this, and I guess we need to create a file system structure and then recursively iterate, recursively walk through this structure to find directories that are at most this size. Okay. Guess we could model the. Let's close the terminal and let's close the sidebar. How do we model this file system tree? So I guess we could call this, let's call it fs node. So each file system node could either be a directory or a file. And if it is a directory, what does it have? I guess it has, this would be, it would have a name, which would be a string, and then it would have children, which we could put into a vec of fs node. And if it is a file, it should have, I don't know if I actually need the file name, probably not, but because it doesn't ask us to do anything with the file name, so Maybe the names are unneeded, but we're going to keep it anyway, like when we parse it, and then maybe we can throw them away. It should have a name and a size, usize. Okay. And I guess we could also put sizes on the directories. Well, I'm already thinking about like how are we going to compute the sizes. It's like a classic recursive function, but we can keep those sizes in the directories themselves, maybe. So we could have something like a size that could be an option of usize. So they could be uninitialized, and then we compute them all and we keep them here, or something like that. But I guess we can think about that later once we have parsed this thing. So we could have a function fn, so that we could call parse file system from terminal output, and we're going to have the terminal output as a string reference, and this would return a fs node, which I guess would be the root node, something like that. And let's do let root be this blah blah blah. We're going to pass the input of this challenge for this, and let's then just print line this thing as a debug, and we will have the root. So that should be quite a challenge already, right? Because we have to parse this thing. So how do we parse this? I guess we could also, like, this is not actually parsing. We would actually be like inferring or calculating the file system tree from the terminal output. So maybe we could say calculate fs tree, and actually I want to remove the word parse from here, because maybe we could pre-parse this terminal output and convert it into like a vector of commands. So we have like a well-formed thing, and we separate the two concerns of having this calculation of the tree and the parsing of the commands. Right? So that makes sense, because each command, I mean, there are only two different commands, but we have to know how to parse this thing. Like to interpret that an ls command is followed by the output. I don't know if it makes sense. Like, how are we going to actually do this thing? You're surely going to need like a current directory that we are in. And as we, yes, if we have like a current directory, we can have the ls outputs, and we, for instance, if we start with current directory of root, then we have a ls, and we know that the ls is on root, and we know then that each of these things is in the root directory, and that way we can construct the things, right? Kind of. I think so. Each time we have an ls, this lists the things that we have in this current directory, right? Yeah. And I guess we can initialize the directories with empty children whenever we see it there. And then when we cd into them, we can keep on parsing. Right? Something like that, kind of. It's kind of complicated, I think. Okay, let's think. Let's sketch out the the solution, assuming that we know how a command. Let's assume that we have parsed the commands into either ls or cd, and when we cd, we'll have a string, which is like where we are changing directory into, and this from commands, we're going to calculate the file system tree from commands. And so this will receive commands, which will be, let's say, a slice of command. And actually, ls should have an output. And what should the output of ls be? Maybe a vec of lines, something? Yeah, let's say that, I'm not sure what I'm sketching out here, but let's say that ls has an output like this, right? So we're going to have these commands that we're going to receive here. So let's see, if we start by the root, the fs root, and I guess it's going to need to be mutable. It's going to be an fs node of dir with name / and children and empty vec. You can probably then create some constructors for this. This needs to be a string, okay. And we are going to iterate the commands. So let's say for commands, in commands, let's do what? Well, I guess it depends on which command that we are receiving. If it is an ls, let's actually start by cd. What are we going to do if we have a cd of some arguments? Well, it depends on what that argument is, I guess. So this arg let's see. If this arguments, again, for, this is going to be a match inside the match inside the for. Very nice. Typical parsing. Or not even parsing, this is like after the parsing of the comments. So if the argument is dot, I guess we can start like, if it is the, actually this output starts by change the directory into the root, but then it doesn't do that again. Does the actual input does it more than once? No, the input does it only once, so that's nice. I guess I also forgot to copy the input. Let's start with, no, this is not the input, this is the input. Well, we won't be using this until we actually know how to parse it, but say day 7 txt, paste this, and okay, so if it is, let's here return the fs root, so it doesn't complain about everything. What is this command? I guess we have to qualify it. So if the argument is the root, well, we are going to need, what do we need? A current directory, like let's it be current there. What should this be? Should this be an fs node or just a string? Maybe we could be happy to have a string. And let's say if the cd argument is a slash, we are going to make the current directory be root again. And if it is ... we're going to need to go to the parents. So, okay, we could have in this fs nodes a pointer to the parent, but that's asking for trouble in Rust world, because ownership gets very, very complicated. Instead here, like each directory owns the children, so and children don't have parent references. So I think instead of having a current dir, we could have like a current dir stack, and yeah, have something like, maybe we can initialize this with an empty vector, and yeah, whenever we find something, we push it into that stack. So if we then have the root, let's say that the stack is empty, so we could do curdir stack clear. Does clear do what I think it does? Yes, clears the vector. Nice. And if we do the dots, we could do current directory stack pop. What does pop do? I guess it returns an option. Yes, and we expect to have popped something. So should their stack should not be empty, and otherwise, if the argument, well, is anything else, let's say it is a, yes, otherwise it should be a directory name, and we could put this into the current directory stack push the name, something like that. Of course, this doesn't like that expected a string. I guess the commands could use string references instead of actual owned strings, because this will come out directly from the input. So this will need a lifetime annotation. Yes, Okay. This is getting a bit hairy. But let's plow on and see if this kind of things make sense. So yes, we are not doing an exhaustive match, and here so the current directory stack should be a vec of this. And what are you complaining about? I must have incompatible types. Okay, so can I put something like this? Okay. Yeah, we are like discarding this value. That's fine. Yeah. And then what happens if the command is an ls with output? I guess this thing could be, since we assume that they are output lines, let's call it output lines. So if it is an ls, what are we going to do? So we have the current directory stack. With that, we could go. Actually, these output lines is a bit of like we are going to need to do some parsing here, right? Okay, let's not. We could have already parsed these output lines into what they mean. Like they could either be a directory declaration, or a directory line, or a file line. Let's do some parsing here, maybe. So for each of these lines, for line in output lines, you're going to have, I guess, any of these lines is a two-word thing, so we can do line split once by a space, and then have the first part would be either dir or size, and the second part is always the name, right? Yes, okay. And we expect, actually, what don't you like about this? Yes, it's an option, because maybe this could fail if there are no delimiters in the string, but here we expect to have line should have 2 words. Okay. This is getting complicated. Let's continue on. So if the dir or size is actually there, then we know that this is a directory. Actually, what we are doing in this for is we are computing the children that the current directory has. That's what we are doing, right? Yes. So we could actually call this thing, let's children of vec of fs node be output lines, then yes, iter map. We are going to map these things. So if this thing is there, then we are going to make a directory, an fs node, a new directory it will be. So the name will be name, that we already have, and children will be, well, we just found the declaration, so it will be an empty array at first. And else, we're going to make an fs node of file, right? I hate this kind of errors that highlight everything. So let's do cargo run. Oh, okay, yes, we are doing a map here, so we need to collect these things. Collect into a vector. Okay, nice. Here the dir expects to have a string. Right, let's do that. To string, I'm fine with that, and I'm fine with. We can take a look at the conversions and things later. And the size, the size should be the dir or size. Parse and expect size should be a valid number. Okay, so these are the children of the current directory. Right. We need to actually, what do we need to do? If the current, like when we start, the current directory will be the root directory. But once we are like changing directory, we have this current directory stack. So I guess from this stack, we could find the directory starting from the file system root, and then mutating that to put in these children, right? Something like that. Does that make any sense? I think so. Damn, this seems quite complicated. But let's try to see if that makes some sense. I'm sure that we could have a better way of doing this, like more like a recursive algorithm or something. But let's see. Okay, we have the children. Then we need to find the node that is that we are currently in this file system, right? So how do we do that? So we are going to iterate the current directory stack. So let's say let's mute current directory, starting with the if you're going to start from here, that's going to be trouble. Dang it. we're going to have like two different mutable references to a file system, like starting with a root, right? So what should we do here? So if we start with the current directory stack, we could like move into the children, like the first directory here will be the first children of root, then the second one will be like going into those things. We could, I guess, find, let's think. Can we say like something like, man, I'm having a lot of trouble thinking about this. Let's see. Let's say current directory. Let's sketch it out. Find directory node starting from the fs root and using the current directory stack. Okay, so going to generate this function. Let's call this thing node. Let's call this thing directory stack. And let's say something like, if the directory stack is empty, then this thing should be this node. And this should actually, what should it return? A reference to a node, right? But we're going to want to mutate this reference. So that's going to be a problem, I think. But let's say, or else, well, the node should be a directory, I think. So let's this node. So we know, else we know that the directory stack is not empty. And so we expect this to be a directory. And yeah, we are going to extract the children from here. Let's assign the node, or else let's panic and say node should be a directory. I have no idea what I'm doing at this point, but let's see. So now what? Now we find the child that has this name, right? The name of what? Of the first thing on the directory stack. So we're going to have well, children iter find find the child. Oh, and I guess I cannot even ask for name because this is an FS node, and we didn't do like both FS. Maybe this could be a struct with that always has a name, and yeah, something like that. But then this is already quite sketchy. And we haven't even gotten into like parsing the commands yet. Am I missing something? Like, could we actually make this in a more direct way? Because let's look at the actual terminal outputs. It starts by changing the directory into root and listing the root, and then changing to A and then listing A, and then like it's doing like depth first search, and then it's popping twice, and then it's changing the directory into D and then listing this D. So actually this thing has a very similar shape to what we see here, and I wonder, like, could we transform this into this in a more direct way without having to do all this recursive data structure? Actually, do we need a recursive data structure? Can't we have like a more plain data structure with file names and sizes, like fully qualified file names and directory? Like, yeah, if we consider, like, for instance, a nested file like this one, or I guess FG, like F is actually /A/F, and I here is /A/E/I would be like the full path. And if we have full paths, we wouldn't need a nested structure, I think, right? And with those full paths, we could tell which file is inside of each directory if the file, like the full file path, starts with the name of the directory. And that seems like a much simpler idea, right? Like, we wouldn't need to actually we could we don't even need to parse these things, these commands, so thoroughly, because like whenever a line starts with a $sign, we know it's a command, and whenever it doesn't, we know that it is part of an ls output. Like, there is no other output, right? So I think we can process this thing line by line, and whenever we find the CD, we change the current directory and pushing into the stack that like we were doing before. But then whenever we find something without a $sign, we know, we know that, for instance, a directory A exists within this, that will be in the current directory stack. So I think we could do a much simpler kind of parsing. Okay, let's let's copy what we have here. Actually scratch that. So let's comment all of this, and let me see because that sounds like a much simpler thing to do. What do we want to do? Let's sketch it some other idea out. So we are going to parse fs from terminal output. So same idea as the original one. Terminal output is gonna be just a string reference. We don't know what we are going to return from here, but I want to return something like a more like an array of things, or a vector of things, a plain data structure. So we could say, actually, we could track the files and directories separately, because we always know which thing is a directory and which thing is a file. We don't need to have like a unified node thing with the two of them. You can treat them separately. So let's say something like, let directories, or let's abbreviate these things to always say dirs. So directories is going to be a vector of string, or let's say their paths. So these are going to be the full paths of directories. Yes, I think. Let's initialize this. Actually, we could start with knowing that the root exists. And let's say file sizes. And we're going to have a bag of tuples with string and usize. And this one is going to be empty at first. Instead of file sizes, okay, so we're calling name to the name of each file and each directory within their parent directory, and let's use the name path for like fully qualified paths. So this would be actually sizes by file paths. Yes. Okay. And we are going to iterate. So for line in terminal output lines, we're going to do parsing here. So if the line starts with $, this, then we know we are in a command, and otherwise we know that we are on an ls output. That seems fine. Actually, we could start by doing something like let words, because we are always going to need to split things by space, I think. So let's do line split split by space and collect. We are going to collect into a vector. So this can be transformed into words. I guess starts with the first word, or yeah, if the first word is this, is the $, then we do this. And what we do then? We're going to match on the second word. We're basically doing the same as here, but directly with the input. if it is, it could either be CD or ls. So we're gonna have CD, we're gonna have ls, and otherwise we're going to say unreachable, invalid command, I guess unknown command, this thing. Okay. Yeah. Okay, so here it's actually parse, called this thing parse file system from terminal output and passing input here. So for the CD, we can actually do something very similar to what we were doing before here. This wasn't all that bad. So when we are doing CD, we are going to uncomment this. And actually, we're going to match against the third word, which should be like the argument to CD. And the current dir stack, we could do what we were doing before also, right? Okay. This looks more or less promising. So now that we are not in a word that's in a line that starts with the $sign, we know that line is a ls output, is part of ls output. So I think we don't need to do anything when we find ls. So what do we do then? We can well, parse this ls output. So we are going to have let's same thing as before. Their size is going to be words. It's going to be the actually the first word. Yeah, and let's name. It's going to be the second word. Right? Does this make sense? I think so. Yeah. So from this, basically, we know yeah, let's say something like, let's try to print something that's and run this thing, because we haven't run we haven't tried running this day in so far. So println, actually we could say if the dir or size is there, then we are going to print directory dir size in, and let's print the current dir stack, or otherwise let's do file. No, actually directory name in blah blah blah, and otherwise is file name in, with the size of their size in here. Okay. If we do cargo run day 7. Okay, we did have an output actually. We didn't crash. Nice. We have unused variables. Yes, but directory A in and nothing. Yes, this would be the root. Then we have 2 files, C, B and C. Does this correspond to? Yes, good. Then we have directory D. Yeah. The directory E inside of A. Yes, we cd into A and we find directory E. That's very nice. Good. So we can actually, instead of printing these things, we could put this into these data structures. Right? Or am I missing something? So we could actually have, okay, let's not think about the full case. So we could have a full path be this current directory stack join. If we join by slash, right? And then we put the, okay, but if it is the, if it is empty, then it's nothing. Good. And that means that we are on the root. But if it does have something, we need to join it with the name of this thing, right? Seems to be the case to me. I don't know if this stack makes sense. Maybe we could already have like the current directory path, a current path, and start with slash, and then we would have this, the cd be a bit more involved here, but here we could just join that. Oh, well, let's think about that later. I think we should concentrate on getting the answer to the first part, and then read the second part to see if actually this structure for the file system makes any sense, or if we actually need a nested structure like we were trying before. So okay, let's try to get the full path. So what should the full path be? We could have the current directory stack join by join by slash, and then we have to append a slash to this, and then the name. I don't think that strings like to do this sort of thing. Like full path should be a string, I'm pretty sure. And I guess we could use a format for this. So we're going to have what? The current directory stack joined, then slash, and then the name, right? If it is the root directory, this will give us a name like, well, let's see. Let's just print these things. Print line. Yeah, let's just print this full path. Comment this, run this. You didn't like join because probably you need some string. Okay, now you like it. So when, yeah. Does this make any sense? Actually, I would like the full path to always include the starting slash, because then we are going to ask for inclusion with that slash. So how do we do that? So if the current directory stack is empty, then no, sorry. Let's think. Actually, let's do a mutable string. Why not? Which will always start with this. Or I guess we would say string from slash. We always start with a slash, right? And then we append full path append. Don't we have append? Should be a mutable string, so concat. I'm missing something here. Rust append to mutable string. I'm not sure. I'm not sure if I've ever done this kind of thing. Push stir. Okay, cool. There's a push, so we can add push. Okay, we have a push and push stir. So I think if we do cur their stack join by slash, do you like this? No, you don't. Why don't you like it? And you found a string. So if we push stir, can we do something like this? Maybe yes. Okay, so we start with slash, then we push everything joined by this, and if we I think I'm overcomplicating this thing by a lot. Right? Yes, I think I am. Actually, what we had here did make a lot of sense. We just need to put a slash into here, and this is already good for the case that it's empty. So if the current directory stack is empty, we are going to do something else. We're going to have this format blah blah blah. So if it is empty, then we're going to just do format slash the name. Yeah, and then print the full path. Okay, now they do seem like full paths. That's very nice. And let's see if now we can say if the dir or size is there, then this thing is a directory. So let's push it into the directory paths. Push the full path. And if it's not a directory, then we need to parse the size. So let size be dir or size parse, and expect size should be a valid number. Okay, and finally, how was the other variable called? Sizes by file path. What a mouthful. Let's push the full path and the size. You don't like this because these are not mutable. Of course they should be. All right, and finally, let's return those things from this function. So we're going to have their names or their paths, and sizes by file paths. Actually, we could have, well, let's save, and it's complaining. Add the function return type. That's very nice. Yes, let's say let's dirs and files be this. Okay, and now the magic. Let's say that for each, what do we need to do? We want to find the small directories. So for each directory, iter, let's going to map their name or their path, let's say. We want to find the files that are contained in that directory, right? So files, iter filter. Oops, this should be a file path, and if their path, no, sorry, if the file path starts with, it's not suggesting anything for some reason. What is the file path here? Oh no, it's not file path, it's file path and size, which I think we can ignore for now. If a file path starts with the directory path, okay, what are you complaining about? May outlive or value their path. Why? Oh, no, we are not going to, we don't want to map to this. We just want to filter the files and then map to the file size. So file path, which we are not going to use now, and the size that we will use, we map to the size. And then actually we want to sum all of this. And this will be the let file size. Does this make any sense? Actually, I'm missing some parentheses here. All right. File size, type annotation needed. All right, you are in usize. Very good. So here we are mapping directory paths to these file sizes. No, this is not the file size. This is their size. And then we actually want to filter the directory. The directories, they have a directory size less than or equal to 100,000. If I can type. Okay, what this would be small dirs. It's gonna be this. The size. Okay. And finally, does this make any sense? Actually, let's print the print line, their size, this thing, and what do we want? We can print the answer, I guess. Let's just return the answer. Formats. This would be what? The small dirs sum, I think. Some will need a type annotation, if I'm not mistaken. This would be usize. Are you happy with this? This actually looks promising. We don't have the name for this directory size because we lost it. Actually, we do have it. We can say their path here. So the size of the root is 48 million blah blah and ends in 65. Is this correct? Close, close, close. 45 and ends with 65. Okay, and the answer would be 95437. Yes, indeed. Oh. Awesome. Let's copy the actual inputs. Dang it, this one was a pretty involved challenge. Let's see. Well, okay, we have a lot of output for different directories. I'm all right with this. Let's try this answer and see if we did a good job. No, that's not the right answer. Okay. So my guess was this thing, and it wasn't the right answer. Now, how do we debug this? So this is well over 100,000. Maybe we can print the small directories or something. but oh, I guess there is something I didn't consider. Some directories could have, yeah, I think this starts with, it's not exactly right. Because I think we should consider the slash, because if some directory, for instance, say, I don't know if I will find anything in here that exemplifies what I'm thinking about. So yeah, let's say if we have a directory path that is, I don't know, /a, and the file lives in directory ab, /ab, then it will start with /a, but we should be checking for /a/ here. So let's try to do it. Maybe we could have the directories be and end with a slash, the directory paths. So here, well, this doesn't need to be immutable, of course. And if it is, yeah, here let's push the format of this plus a trailing slash. So it gave a different answer, and we can refactor this afterwards. So let's try this different answer now. Submits. Yes, okay, that was the problem. Yeah, okay, maybe like the starts with check is a bit finicky, but now that we have trailing slashes for directory paths, I think that should work okay. But let's see if this cheesy solution that we did without like nesting the nested structure of the file system actually can be reused for part 2, because otherwise we will have to refactor lots of things. Okay, part 2. Now you're ready to choose a directory to delete. The total disk space available to the file system is 70 million. To run the update, you need unused space of at least 30 million. You need to find a directory you can delete that will free up enough space to run the update. In the example above, the total size of the outermost directory, and thus the total amount of used space, is 48 million. This means that the size of the unused space must currently be, well, this thing, 21 million, which isn't quite the 30 million required by the update. Therefore, the update still requires a directory with a total size of at least 8 million blah, blah, to be deleted before it can run. To achieve this, you have the following options. Delete A, which will increase the unused space by this. Delete A, which will increase the unused space by this. Delete D, okay, or delete everything. Directories E and A are both too small. Is actually A too small also, because this, yes, because this is not in the millions. Deleting them would not free up enough space. However, directories D and slash are both big enough. Between these, choose the smallest, D, increasing unused space by this number. Find the smallest directory that, if deleted, would free up enough space on the file system to run the update. What is the total size of that directory? Okay. then actually our solution for part 1 is pretty well suited to do part 2 also. So here, instead of having the small directories, we could collect all the directory sizes and then filter the small ones. So let's extract this thing, call it their sizes, and it's actually going to be a vec of usize, I guess, and we're gonna collect here, and then we can compute the first part answer directly. Sum of the total sizes, so let's call this thing small there's total size, and we're going to filter the small ones and then sum this thing, not iter, and here we're going to print the small there's total size, which should be the first answer. Now we're going to return that. And here their size is a double reference. Okay. And this probably needs a explicit size, explicit type usize. Okay. Do we still get the same answer? So let's also remove this print that we are doing here, and let's see. Yes, we still have the same answer. Very good. And I guess here we can get rid of the intermediate variable. So this should be directory sizes. Sort of makes sense. And well, we can see what we are going to do with this appending of the trailing slash, but we can see that after we do the part 2 answer. So the part 2 answer should be relatively smart, straightforward. So let's say file to delete size will be. So what do we want? We want to have their sizes. We're going to do something similar to before, but instead we are going to find the directory sizes that are bigger, like big enough to free up the space, and then we're going to get the minimum out of those. So we're going to get filter the size, anything that is over. Oh no, actually we need to find the unused space. Yeah, okay. So so yeah, we need to find out how much do we need to delete before, like to save. Okay, let's first do then. I guess we can trust that the total size will be in the first directory, which will be the root. So let's say unused space will be 70 million minus their sizes, the first one. First there is roots, and then that refactoring was very weird. Let's print the unused space. What's you didn't like? Okay, sorry about that. Okay, so the unused space is 25 million something bytes, I guess, or whatever this file system uses. So we need to free up a file that's actually this is the unused space, okay, and we need this size for the update. So we can do something like let space to free up. How much we need to free up is this minus the unused space. Okay. This would actually be, well, we are guaranteed that this should be a positive number, like from the inputs. So I don't care about checking for underflows or things like that. So free up, how much do we need to free up? Space to free up is, we need to free up, sorry, 4 million something. Okay, which makes sense because it's 30 million minus 25 million something. Okay. So we need to free up something like this. We need to find, then we need to find directories that are this size or more and find the minimum out of them, right? Yes. File to delete size would be space to free up. Yes. Better, greater or equal to space to free up, and then we're going to get the minimum out of those. And yes, we need to dereference twice. And let's print this thing. This is an option, and of course we are going to expect there should be a directory with enough size, should be a big enough directory to free up space for the update. So lots of jargon from the part 2 description. Okay, let's actually, I'm a bit scared to run this with the actual input. Let's first run it with the dummy or the sample input. So run this. Okay, I think, so it's 24 blah blah 42. Yes, okay. Then now let's run it with the actual inputs. And it's this number, so it is 4,044 something. And let's try it. Oh yes, okay. All right. This was quite a challenging one today. We can totally get rid of my first attempt of parsing this terminal output into an actual tree. And we can try to improve this solution now. Okay, let's add everything to Git and try to make some improvements. So first of all, are we okay with parsing this file system from terminal output thingy? Do we actually need I was wondering, okay, there's a couple of things that I was wondering about. First of all, this thing of like formats, like adding the trailing slash to directories. This is kind of a hack, so I guess we could do something like here, if it starts with this, the directory path, and then has a slash, then I guess that would be okay. Also, I think does the dir path have like a length? What does len mean? It turns the length of the string in bytes, not chars or graphemes, of course. Of course. So yes, I guess we could do something like, if it starts with this and the can we say like byte add or something? And the byte at the their path len is the slash expected U8. How did we? I think it's like this. Yeah, I think this could be another alternative to putting the trailing slash here. So here we could just put the full path, and does this give us the same? No, panicked. Try to subtract with overflow. So we did a wrong calculation. Fine. Starts with their path, and Does that make some sense? I think it should. Like, if we do the format here, of course this is not better in any way. Actually, it's worse because we are doing this more times, I guess. But let's see. If it starts with this, and we can take a reference to this, I think. No, it actually didn't like this. Why not? Same underflow behavior. So now I don't understand what's happening. Let's go back. We don't do this. We don't do this either. Wait. What are the changes that we have here? We only changed this first directory. Okay, we can totally add this. And if we run now, we do have the correct solutions. Okay. So what's going wrong here? There are paths. If we push the full paths into here, then shouldn't it be the same? Like, if we run now, we're going to have an incorrect answer for the first answer. Yes, but here, if we say format, the dir path, and then a slash, format, and we take a reference to that. What the hell? Why is this not working now? It should be the same, right? Can we maybe let's print the directories, I guess. Println there's, and for there and there's do println there. We can do this. We have this thing. These are the directories, right? And if we undo this change and we put the full path there, the directories include the trailing slash, and now we can just ask with this, and it gives the correct answer. I'm very confused of why this was failing with the format. Can we maybe put let's prefix prefix the format of the their path and slash, And then here we can push this thing again. This must be a very dumb bug, but I'm not finding it. Let's pass a reference to this. Run. Still with the underflow. So how is this any different? Like, we have the dir paths, and now without the trailing slash, let's print here. So looking for files in, and well, their prefix. Like, it's the same thing, isn't it? It ends in with this tvrq slash. Can we print out, because this is doing an underflow in here, we can print this first answer here, println this thing. This will be answer 1. The answer 1 is still the same thing, isn't it? Or not? Not really, right? Let's actually maybe stage or stash these changes, tmp, and so this number 1729. Yes. No, wait. It's not the same, right? Here it is. Yeah. 1,079. Yeah. 25. Yeah. So the first answer is the same. Oh, okay. So the root directory calculation is screwed up when we. Yes. Okay. So git stash puppets. Oh dang. Wait. Let's not screw everything up now. Let's copy this just in case. Okay. So do we have the correct answer now? Yes, we do. Okay. So let's actually, just in case, commit this with a whip day 7 solution. And okay, when we were doing like the format here, it was different. We were screwing up with the case of the root directory, and then that's why the here it was underflowing. So we weren't calculating the root directory size correctly in here. So is it okay to maybe push this with a trailing slash? Maybe it is. The full path, however, is actually wrong for the root directory, I think. Like if we do, if we go back to printing the, let's print line. Well, actually, let's say first directory, first there is this, and let's say there's the first one. Okay, no, we have a slash. What? Shouldn't this be double slash? If we have like full path and then we appended another slash here? Oh no, because when we are in the the current directory, wait, what is the second one? No, okay, it seems like when we are changing there into this, like when we are on the root, we never list we never see the name slash in a directory name. We just start with this in here, right? Yes. So we don't need to handle this in a special way. Like we are never pushing it in here. The slash it's already in there. So this thing works regardless, but we cannot do the formatting here because like if we do the formatting here, we have to be aware of the root. We cannot append always slash at the end. So okay, let's keep it this thing for now. Can get rid of this. So the other thing that I was thinking about was that maybe we don't even need the to parse this thing into like the directory paths and also the sizes. I think we could have like compute directly, the directory sizes when we do this. So yes, okay, let's do commit amend day 7 hacky solution, let's say. It's not a work in progress. I think this is a solution that's worth committing. This could be reduced into a filter map, I think, but I'm okay with this. I'm also okay with this, and with this. Actually, this print line was needed, so let's actually amend this, and how about this message? This should be a big enough directory to free up space for the updates. Yeah. Sure. And then this code, can we improve something from here? Probably lots of things. Okay. Line is part of ls output. Okay, and then here we do the special casing of when we are in the root directory. Yeah, and we finally do this. Okay. Yeah. So let's amend this too. I am okay with this. Oh, no, it's okay. What I was thinking about was maybe we don't even need to parse, like return the paths and the sizes of each file and do this calculation of their sizes here. We could probably calculate the directory sizes from the terminal outputs directly. So I want to give that a try and do less computation on here, because like whenever we are doing this walk here of the output, whenever we find the file, which would be this case, we know the size of that file, and we could know, like whenever we parse a file, we could update the sizes of all the directories that contain that file, which would be all the directories on the directory stack, and that's it. We would have all the directory sizes right away, I think. Yes, I think so. Wouldn't we? So let's try that out. Let's say if we have, instead of these two things, let's have directory sizes right away. And this would be a hash map of string to usize. And string would be, the keys would be the full paths, right? So, well, let's do a hash map new here. Why don't you like this? You can import it. So we have the current directory stack. Okay. And here we have the size. And maybe we could, if we have the full size, actually, I would like to have like the path of the parent directory, right? So let's say let's their path be something similar to this. That is going to be simpler. If the current dir stack is empty, then it's just this. It means that we are in the root, and else we're going to be in here. Actually, this is the same either way, right? If we are in the root, the current dir stack is empty, so this is, I think, more generic code. The dir path is just slash and the current dir stack joined by slash. Good. And this is the directory path of my parent directory here. So what do we need to do? Now, actually, we have to increment the, I think this is not exactly what we want. what we do want is to let's think. Let's move this a bit down. Let's keep what we were doing before, but we have to update all of the directories up in the current directory stack. So how do we do that? Well, we could go for I in 0 to current directory stack length. This doesn't include when it's 0, it doesn't do what I want. Okay, but let's think about that later. Yeah, we're gonna have this dir path to, but we're going to like go from 0 to I. So we're going to be increasing this. And let's do their sizes in their path. Plus equals size. Did you like this thing? Expected reference found a string. So can I pass you a reference then? Cannot assign that data to an index. Index mode is required to modify it. Okay. Yeah, well, okay, this thing, how was this done? Get mode. The key would be that their path. This should be a reference. And now, what do we want to do? Actually, we would like to get or insert, right? Let me actually check how Rust hash map get or insert or update or set default. I'm pretty sure this can be done in one operation. Seems to like this kind of thing. Entry. Entry is, I think, what I want. Yes. So, like, get me the entry for their path, or insert 0, and let's increment it by size. Do you sort of like that? No, you don't. Why not? You need to dereference this. Sure. You want a string. Sure thing, you can move this string here. I'm fine with that. And okay, that's pretty good. Can you also increment the sizes of the root? That's equal to size. Of course not. I think this was the same error as before. Cannot assign. Yeah. Okay, let's just do the same thing and not worry about that. And also, can we do this will actually start from 0, so I'm pretty sure we can go up to the length, and yeah, for an empty thing this will start with 0, and this will go from 0 to 0, and this will be an empty slice, and it will have already updated the size of the root of the root directory. So I guess we could print the directory sizes and see what's going on. Println, let's print these directory sizes. Their sizes. It doesn't like that, of course, but we can print debug it. Well, maybe I can use the sample input and run again. Is this what I want? I think it is. It was something like this. Yes, these are sizes that I sort of remember from the description, so this seems nice. Okay, yes. So I think we can implement this with just returning this their sizes. And this shall then return a hash map like this. Okay. And we don't need to compute these two things. And whenever we find the directory, we do nothing, because we know that we will update these directories. Yeah, I'm pretty sure about that. We could actually insert here, and then here we wouldn't need to do the or insert thingy, which is fine. Yeah, but well, we can try that out later. We don't need that either. And now that we have the directory sizes, we don't need to compute these directory sizes here, which is very nice. And okay, their size, directory sizes is now not a vector of, it doesn't have the same shape as before. So what do you complain about? Blah blah blah. So okay, their size here, what is this? Actually, we only need the values, right? yeah, we don't even need the names, I think. So, is that all right? I think so. Oh, well, I guess here we would need, there's sizes of the root to know this kind of thing. But okay, here could ignore the name and use the size. And what is size here? It's a U size. So what don't you like? The trait Sam is not implemented for U size. Of course not. So I guess you would map yeah, no, instead of iter, we would just have values. And that's it. Values. And you're happy? Yes. And here, values. And you're happy. And we don't even need this comment. Cargo run 7. I think this is okay. Let's have the actual inputs. Run this again. And yes, this seems like my actual answers. Very nice. So this actually works. And I think I do prefer it better than what we were doing before. It is slightly less code. Actually, there is an unused thing here. Yes, this full path, we don't need it. We don't need to do the special casing of the root directory or anything else. Even the name of the file name is not really needed, it seems, unless we do something here like insertion of this thing here, maybe, yeah. But other than that, I think this is pretty awesome. Okay, so let's actually add this and see if it would be better to do something like the sizes, insert, and here we need a string, so name to string and value 0. So we know that this directory exists now, and here we would instead of doing entry, this or insert, what does it return? A mutable reference to the value which we can update. This has an empty. All right. So we can also do like or updates. No, get mute, I think. It does. It's an option. Kind of weird. Their name. And you don't like this, but you should like if you unwrap it. Actually, their name. No, their path. Sure. Would this work? Well, we would also need to start with the sizes, insert the root size starts at 0. To string What does it do now? Well, it panicked. It tried to unwrap. Yeah, okay. So, but it's not telling me. Let's just print here. Println updating their path. Updating this thing, and okay. So you don't know about the okay. So yeah, no, we shouldn't be their sizes. We shouldn't be inserting this thing. No, I'm super fine then with the entry solution, because like, okay, wait, cancel. Here we shouldn't be inserting the name that we got from here. We should be inserting the full path, but I don't want to compute that. It was the previous calculation that we were doing before. So I'm fine with what we have here. So let's undo this change. Use the entry API here, or we initialize at 0, so that is fine. And we don't use the name, right? We don't need the name. So we can do the size, and we can actually do, if it's not there, then we have the answer. We don't need to do anything about the there lines. Yeah. Okay. I think I am fine with this, right? Yes, yes. And now, okay, this shouldn't be called parse file system from blah blah. We should get like calc their sizes, directory sizes from terminal output. Yes. Okay. Yes, indeed. And what about the current dir stack? Am I okay with this? I think that I am. Maybe we could actually start the current dir stack with, like, what do we do with this current dir stack? We could have the full path in here, I think. Actually, would that be any good? Maybe it would. I mean, let's try it out as a last thing to try out before we wrap up this thing, because oh man, I need to do other things. Okay, so current dir stack, we could make it a vector of actually the full paths, and we will start with this, call this into string, and here these two things are the same. No, actually we don't want to clear, we want to just, what do we want to do when we have that? Actually, we would just push or no, like replace. Is there a replace? Render stack is just this. We just make it a new vector. We are going to like replace everything. Okay. And if it's this, then we're still popping. And if it's something else, if we have a dir name, we will do what? We could get the current there is going to be the current dir stack last. We're going to expect to have something. The stack should not be empty. Yeah, okay. Sure thing. And we're going to push in here the formatted thing. So I guess we could ask if the current there is the root, we're going to do formats slash and then their name. And else we're going to do a different kind of formatting. Else we're going to do their and their name. Something like that. And if we do this, we have a render stack of like fully qualified paths. Then we don't need to do this formatting here. Wait a second, I'm having a phone call. Can I pause the recording? Let's pause. Okay, I'm back recording. Sorry, I had a phone call and I should be attending to that soon. So let's wrap this up. What were we doing? Okay, we have a render stack with the fully qualified paths, and therefore we shouldn't need to do this formatting here. So we could say for their path in current their stack, no formatting needed. And what about this? Do you like it? Their path would be a string. This entry passes a string, but doesn't the string get moved? Oh, yes, and I'm consuming this here. And I think Rust is making sure here, borrow after move. Move occurs here. Yeah. Here we are consuming this thing. We should not do that and do normal iteration. We have now a reference to that string, and now we can clone this thing, I think. Yes. Okay, now does this still work? Yes, it does. Is this any better than what we had before? I think probably not. Let's see. We did we did change the current directory stack, so that's not too bad, but then we are formatting the things here. I guess we are saving some effort here, but really, yeah, no, the code was clearer before, I think, and current dir stack is fine to have these names. So let's revert this, and let's yes. Let's say keys are full paths, like full bar, full directory paths, like this. Okay, good. And let's check the changes. Well, let's add this, and let's check the changes. So yeah, this is a very nice change, to go from having this thing that returns the directory paths on one side and the sizes of the files on the other hand, and then doing this starts with this starts with check. That is kind of quadratic also. Now we don't do that, we just simply update all the directory sizes whenever we find a file inside those directories, which is very nice, much more direct of a computation and much less code to deal with. So I'm happy with this. Let's commit this change. So in compute directory sizes more directly when parsing the terminal outputs. Okay, so I'm fine with this. Let's push and let's wrap this video here. I think this was a pretty long one, but it was a fun one also. So if you have been, thanks for watching. Bye bye.